Hello and welcome to our second edition of our C2 chemical resources topic, and in today's lesson we're going to be looking at materials from rocks. Don't forget, if you have any problems, give me an email or you can tweet me on these numbers here. Thank you. Okay, so our objectives for today's lesson are these. So, materials from rocks. By the end of this lesson you should understand how rocks can be treated to extract metals or other resources from them, and how copper is extracted using electrolysis. Now, many materials actually come from rocks in the ground, and we can have a look at a few examples here. This is hematite. Now, hematite is a rock that we can use to extract iron from. This is bauxite, and this is one of the most abundant rocks in the earth, and this is where we get aluminium from. We can also get clay, which is this one here, which is baked to make bricks. And we also have sand here, which we can use to make glass with. Now, these all need processing, whereas other things don't need to be processed. So things like limestone can be used straight away as it is. Marble can also be used straight away, and so can granite. Now, granite you might be lucky enough to have as a work surface in your home. Now, many of things can be extracted straight from the ground, and this means that you may need to have a quarry. Now, with quarries there are quite a few issues that you might have. They can be noisy, they can be dusty, they can take up a lot of land. They can also change the landscape, and also they can cause an increase in local traffic. Okay, now we need to consider the implications of these when we're actually looking to take rocks out of the ground. Now, calcium carbonate, which has a formula of CaCO3, is quite an important mineral or rock. Now, the type of rock that it comes from can be limestone or marble. Now, quite often what we can do is we can heat the calcium carbonate, and we can see what happens when we heat it. Now, calcium carbonate, when we heat it, will undergo a reaction called a thermal decomposition, and that's where we actually break it down into two smaller things. So we've got calcium carbonate that, when heated, will break down to make calcium oxide and carbon dioxide, and that's the symbol equation for that reaction. Now, concrete is quite an important material for building, and it's extremely important for building homes. Now, in terms of your ingredients for concrete, you need to have a bag of cement to 5 bags of sand and 5 bags of aggregate. Now, aggregate is just gravel and tiny bits of sort of scrap rock, and then you need water. Now, how you make this is you add all the dry ingredients together, so the sand, the cement and the aggregate, and you mix them all together. You add the water and then mix again. Then you allow it to set. Now, there are special types of concrete. Now, on the picture here you can see reinforced concrete. Now, this is a composite material. Now, what you can see is you've got metal rods here and here, and the concrete is set around the metal rods. And what this does is it reinforces the concrete to make sure it's a lot more stronger, and you improve the properties of it. Now, as we mentioned earlier, there are lots and lots of different types of rock. There is sedimentary rock. Now, sedimentary rock, such as limestone, is useful for a lot of building materials. There is metamorphic rock. Now, metamorphic rock tends to be a lot harder because it's heated under pressure. And then the hardest rock of all is igneous rock that we mentioned in one of the last episode. Okay, granite could be a type of igneous rock which is extremely hard. Copper is a really useful material that's extracted from the ground. It's a really good conductor of heat and electricity and doesn't corrode or react easily with water and oxygen. Copper is made by heating the copper ore with carbon. Now, this is what we call a reduction reaction, and we'll talk about that in a moment. Now, extracting copper is a really expensive process to do, and it's actually cheaper to recycle copper rather than getting it from the rocks or from its ore. Now, to get the copper, we need to use a process called electrolysis, and I will explain what electrolysis is here. Now, electrolysis, as the word suggests, uses electricity. Now, here we've got an impure copper electrode. Now, it's impure because it contains copper amongst other things. Now, what we do is we put this into a copper sulfate solution. Now, within the copper sulfate there are copper ions. Okay. Now, an ion is something that has a positive or negative charge. Now, in the case of copper, it's positive. Now, what we do is we have an electric charge, and what happens here is the copper loses electrons, and the electrons go round the circuit and come to the other electrode. Now, because they lose electrons, the copper ions are soluble, so they dissolve. Now, the impurities that are in there are insoluble, so they just sink to the bottom. Now, because we've got these copper ions that are short of electrons, we have an electrode here that is full of electrons. So the copper ions move to the negative or the cathode electrode, and they become copper atoms again. Now, in terms of the reactions that actually happen at the anode, which is the positive electrode, we get this reaction. So we have copper atoms that lose 2 copper electrons to become a copper ion. Now, this reaction is an oxidation reaction because electrons are lost. Now, at the cathode, we have the opposite reaction. Now, here we have the copper ions gaining electrons, so they become copper atoms. Now, this is an example of reduction reaction. So the whole thing is what we call a redox reaction. Okay, the redox stands for reduction and oxidation. Now, we need to remember that reduction is the gain of electrons and oxidation is the loss of electrons. Okay, so in today's lesson we have looked at the how we can get materials from the ground. We've looked at the reactions of limestone and marble, which is calcium carbonate, and how we can thermally decompose that. We've looked at how we make concrete and the ingredients that are needed and the method for doing that. We've looked at different types of rocks, such as sedimentary, metamorphic and igneous, and then we've looked at the use of copper and how we can actually extract copper from old recycled copper. And that involves a redox reaction where copper loses electrons, then gains electrons to become a purer form of copper. Anyway, I hope you've enjoyed today's episode, and I will see you next time. Bye bye.